Okay, we'll start the next topic now. We're looking at sine, cos, tan graphs. Okay, so the first graph I want to show you is what does the graph of y equals sine x look like, and we'll use degrees. Um, 0, 180, 360, etc., 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 and this goes up to 1, and this goes down to -1, and this is x, and this is y. So this is the graph for sine x. It goes up, down, and it's back at 0 at 360, and it repeats. Up, down, back at 0 here, and it goes the same backwards as well. Up, down, down, up, and down like this, and then down like this, and like this. Ugly, I know, but you've got a graph that repeats every 360 degrees and goes from -1 to 1. Okay, so if you draw that, we'll do cos next. Draw. Okay, next is cos. So again, let's just put 180 here. What's wrong? Minus 360. 1 minus 1 y x. Cos starts at 1, goes down to -1, and then back up to 360. Down to -1, and then back up to 360. So this is what cos looks like. Yeah. Oh, so long. I don't know. You were late for class, and I'll show you beautiful graphs in a moment. Beautiful graphs. Okay, continue. All right. Tan x now is the hard one. Um, 90, 180, 270, 360, 90, 180, 270, 360, like this. So, with tan, it's not as nice as sine and cos. It's more broken than the other one. So what happens here? The graph breaks every 90, so it looks like this. This is the graph for tan x. Totally different. It's broken at the 90s, or rather, it's 0 every 180 degrees. Okay. Continue? Yep. So we want to know what happens to the graphs if we change them a little bit. So for example, if you had something like A sine B x x minus C plus D. What is the effect of the A, B, and C and D? So let's look at what happens if we have an A, like a 2 or something like this. So I'll just draw a graph here of sine x. Okay. 360 I want. No. Right, good. Okay. So there's sine x. What do you think happens if I put a number in the front? Yeah, if I put an A in front of the sine, like for example 2 sine, it would be stretched 2 times vertically. So watch. So it's now twice as high and twice as low. So the first rule is an A multiplies on the y-axis vertically, it stretches. Okay, what about the B? What happens with a B? Like if you had a 2, if you had sine 2x, yeah, it compresses on the x-axis. So let's just have a look at that. If I had here a 2 in front, so it shrinks. It's like it's half the length. It's compressed by 2. What about this minus C? If I had something like sine x minus 30 degrees or something like that.
30.
Yeah, it moves it to the right on the x-axis. I don't know why I'm writing x-axis, because you can see it's x-axis. Yeah, positive. So, watch for example, let me just clean that up. If I draw sine x, and then if I draw sine x minus 30, you see it moves a bit to the right. The minus 30 moves to the right. And then finally, what does the D do?
Up and up.
Yeah, so if it's a plus, it will move it up along the y-axis. So this is up along y-axis. This is moved along x-axis. This one here is compress on x-axis, and this one here is expand on y-axis. Let's draw one. Let's make up one. Let's say we have 2 sine 2x minus 30 or 60 degrees plus 1. We're going to draw this and then check it with the computer program. So if you can just write this question down, we'll do it together. 2 sine 2x minus 60 plus 1. Okay. 2 sine 2x minus 60 plus 1. Please note, this is not a sine bx minus c plus d. It nearly is, but we'll have to make one small change to it first. So the a is definitely 2. The b is the number that multiplies both of these, so we'll have to take the b out. So what is the b here? 2. And you're left with x minus 30 plus 1. So this is the a, this is the b, this is the c, and this is the d. Okay so far? The way I like to do these questions is by making a table. And on the table I like to write in where the graph starts, ends, min, and max. So before we start, we write in the basics. It always starts at 0, ends at 360, goes from -1 to 1. And then what we have now is 4 effects, 4 transformations caused by the A, B, C, and then finally the D. So let's have a look at each of them one by one. So what is the effect of the A, did we say? Well, that's to expand it 2 units. So which of my 4 change here? 0, 360, -1, or 1? Yeah. What will -1 and 1 become? No, -2 and 2. This is the effect of the A. What's the effect of the B?
The ends will change.
Yeah, it compresses it. So it starts at 0, but now it ends at 180. What's the effect of the C? Yeah, so it will start at, end at, and finally what's the effect of the D?
Start and end of the same.
Yeah.
30 to 10, and then it will go up.
It'll go up. So it'll be 30 to 10 minus, no, yeah, -1. Hang on, why did I write -2 here? Sorry. -1 and 3 then. Now that we have the table, we can draw it. We'll go up in 30s. Hang in there, Zany. Hang in there. We're not too much longer to go. Try not to fall asleep until the end. Right, so we'll go up in 30s. -30, 0, 30, 60, 90, 120, 150, 180. That's too short. 210. And we can continue as well. And we should go up to 3. 1, 2, 3, -1. Like this. Okay. Are you ready now? Can I continue? So what you do is you draw a box around your 4 points. So we start at 30. So in pencil, you would draw a box here at minus 30. Starting at minus 30. Finishing at this one here, 30, 60, 90, 120, 150, 180, 210. We'll draw another line here at 210. Then we draw a line at minus 1. And then at 3. And then we split this box into 4 quarters. So if I go from minus 1 to 3, where do I split this in half horizontally?
Why are you starting at minus 1 of that?
Oh, because I'm tired. Starting at 30. Thank you. There now. Okay, if I split this into 4 quarters, where do I draw the line horizontally? Minus 1, 0, 1, 2, 3. If I want to split it right in the middle, at 1, because that's the middle of the 2. And then what about from 30 to 210? Where's the middle there? 120, which is here. So you have a box, and this is where you draw the sine. And if you think about the sine graph, when we drew the very first one, did we start at the top, the middle, or the bottom?
The middle.
The middle, and then we went up, down, up. If it was cos, where would you start? Top, and then down, up. Yeah. So because this is sine, we start at the top. We start at the middle. We go up, down, and then down, up. Beautiful. If you needed more than this, what you do then is you take your ruler and you copy this box over here, and copy it over here if you need to. So the graph would look like this then, and so on. I'll just leave it like this for the moment. Let's have a look at it on the computer program. So I'm a bit zoomed out, too much. So you can't quite see it, but I think you can. It goes from minus 1 to 3, starts here at 30, finishes at, that's not quite, oh yeah, sorry, here's 210. Oh yeah, sorry, starts here at 30, so that's the start here, and goes up, down, up, yeah. That's it. So I'll just continue it down here and continue it up here. So it's the same.
Is there a question about
Yeah,
graph?
there is. They, not always, about 50% of the time ask you to draw a graph. So the way you draw the graphs is by using a table. You consider the effect of the A, B, C, and D. The only difference is at the very end is how you draw in your box. So for example, if this was a cos, the only difference would be at the end I draw this. Let's try it again. That would be the only difference if it was a cos graph. So it's the same technique for everything here. A good clear table of the effects of A, B, C, D will help you draw the graph. I don't think you have to worry about tan, because I've been here 9 years and I've seen, let's see, it'd be 18, about 24 exam papers. They've never asked to draw tan, I think because it's too difficult to draw. They always ask to draw sine or cos in the exam. So once you can draw sine and cos, you should be okay. the only thing I didn't actually say, which I think most people know, is if the A, B, C, or D was negative. So for example, if instead of 2 sine x, it was minus 2 sine x, it expands by 2 and flips upside down. And what about if it was sine minus 2x, it compresses by 2 and then flips around. So just remember the minus, I think you probably knew this already, but the minus flips the graph around. Like for example, if this is x squared, then this one here is minus x squared. Okay, so just be careful about that one. Okay, so the homework then is question 1 and question 2. And question 3 is optional. I recommend that you do it, but it's only for people who want further practice. You can start these now.